9:30 a.m. on a Sunday morning. I'm impressed. Thanks all for coming. I'm sure more will be streaming in. My name is Chris Woodfield. I'm with the program committee at NANOG. This is the NANOG 72 Hackathon, and thank you all for coming, and we're hoping this will be a really fun day. We're going to get some skills, show off some skills, and we're all going to learn and have a lot of fun, and I'm really excited to see what you're going to be what we're going to be showing off later in the day. Anybody else? Okay, just be able to go. Yeah, find a seat everywhere. We'll probably be changing tables after we do the intro, once we set up teams. Has anybody having trouble accessing the wireless? We just had to correct the SSID, but it should be working now. But yeah, there's NANOG, which is 802.1x. Username password is both NANOG. There is a legacy open network. If for some reason you have trouble with the authenticated network, if you have trouble connecting to either one, please let me know, and we'll see what we can do to fix that. Obvious logistics. We're doing our meals and breaks over here on the other side of this room here. Bathrooms are out the door in the foyer. After the hackathon, or if you want to take a break during the hackathon to go get your registration badge, that is in the Ellington Ballroom foyer, which is further out on this floor. I think it's closer to the elevators. Here is our agenda. We're going to start. Okay, that was incorrect, but oh well. So we're doing 9:30 to 10 a.m., not to 10:30 a.m. I'll be speaking, and then after I'm finished, Bill with Oracle will be doing a Python Ansible Napalm tutorial to get you all started with some ideas. After that, we will break into groups, and I will solicit people who have ideas and want to start a team. And then after the people who have made their proposals have spoken, the rest of you are free to join any team you want and start your hacking from there. Around 12:30, we'll be having lunch. Lunch will be served over here. Feel free to eat there or back at your table, if you don't want to break away for too long. That will go from 12:30 to 1:30. We'll have a refreshment break at 3. Same deal. We'll be putting food out there. Eat over here or back at your table, however you choose. 6 p.m. is the hack deadline. 6 p.m. is laptops down, please. And that's going to be what you're going to do, what you have ready at 6. From 6 to 6:50, we will be doing demos. The teams will be doing demos of your hacks. Don't worry too much about working code. Prototyping is fine. In one day, we found it's very difficult for people to get something that's all singing, all dancing. Concept, prototyping, whatever you can do, don't be embarrassed. I was on a team at the Hackathon last year, and all we had was a PowerPoint deck. So just to set the bar there a little bit without a whole lot of pressure. And then we'll be closing at 6:50, and we'll be holding a raffle at that time. What are we working on today? Configuration management and deployment is the theme we landed on. The tools we're going to be demoing, Bill's going to be showing us a walkthrough of Ansible and Napalm working together, which are both common tools. How many of you have used either of those before? Okay, so we got a bit of experience here. That's good. The rest of us, I'm sure, will be coming up and asking you guys lots of questions as it happens. And at this, where's Bill? Okay, yeah, you're back there. Okay, so let's break into Bill's tutorial, and after he's done, I will come back and make some other statements.
Hello? Can everyone hear me all right? Sweet. If not, I'll just yell. Yep. Cool, thank you. All right. So Wi-Fi went down and came back just a couple minutes ago. That was exciting. All right, so I'm going to talk to you for a little while here. Full screen. All right. Okay, so my name's Bill Booth. I'm a principal member of technical staff at Oracle, and I work in the network engineering department. And I'm on a little team that's kind of embedded inside that department, and I'm responsible for qualifying like incoming networking gear and all the things that we're deploying in our production networks. And so it's a pretty daunting task, and to do that it requires a lot of knowledge of test tools and methods and software development and network engineering. So today my talk is going to kind of, you said about half of you have played around with Ansible, Napalm, like device abstraction. I'm going to go into that a little bit, and I'm going to talk about Python. And so if anyone has any questions, just scribble those down on that piece of paper. Otherwise, you can use that piece of paper. You can just crumple it up and throw it at me if I'm off base. Anyway, so what I'm going to go through is I'm going to go through the importance of knowing how to code in network engineering. Like you'll look on LinkedIn or you'll look on job, like on websites where you can apply for positions, and it says stuff like, looking for college graduates need 5 years of coding experience. So that's kind of what I'm going to go into. I'm going to talk about kind of the way that we layer things. So I first did networking and then software engineering in Python. And what I'm going to talk about is the layers where you can operate as a network engineer or as like outside of development, and where you can actually use development, and you can provide access to like layers above and below you. So accessing all different kinds of devices, providing some sort of markup to non-programmers, and making something that many different people can use. I'm going to talk about some change management solutions, some tools that you can use, whether you bring your own or whether you use something that's off the shelf. And we're going to look at, I'm going to dive in a little bit into Napalm and the context manager that they use. We're just going to talk about that so we can talk a bit about Python. And then finally, we'll talk about development environments and some tips to maybe make things easier for you today. So coding as a network operator. So this is a really big deal. A lot of network OSs have Bash on them. They have scripting languages already present on the system. You can get a shell and you can execute Python code directly on certain network OSs. To be able to know how to code as a network operator is really important these days, because that's what you use to kind of glue everything together. You can arrive at your pretty awesome solutions if you just know your way around a couple simple like scripting languages. You don't have to know C or Java or anything. And huge distributed systems now and networks are making it really crazy the task is really daunting. You're having to operate on thousands of systems sometimes, and to do that, you need automation. So we know that in data centers now, anytime someone has to get up and do something with their hands, you're going to lose money. Any manual or operations is going to, basically, the company is going to hemorrhage money. So we want to cut down on that. So it's nice to be able to be like kind of judge, jury, and executioner and get that stuff tackled. Your work's reproducible, so this is a big deal because you're not going to, the things that you do, when you hand them to me, I'm not going to say, oh, I don't know, it worked in my environment. Ideally, you want to make something you can button up and package up, hand to somebody, it's tangible, and it's reproducible. So you want to be able to, whatever you create, including the things you work on today, you want to be able to be organized and have it kind of compartmentalized. And as far as language choices go, like I said, mostly scripting languages. Python's the big one, although like on these network OSs, usually you're stuck with like an older version with a lot of older packages. So your hands aren't exactly tied, but sometimes you're tied into a certain Python version. So right now, one solution, and I'm gonna go at this from kind of a software development approach. I believe that if you take the approach of using tools that software developers use or processes that development uses, and you treat network configuration and network deployment like code, that you can be organized and you can you can be on top of it so you can do the rest of your work. Right now, if you go out and you look around, on the orchestration layer, you're seeing things like Ansible, Robot Framework, and Salt. Has anyone here worked with Robot Framework? What about Salt Stack? Okay, so these provide kind of like the interface. Like if you wanted your manager to be able to look at something and understand what you were trying to do, you would use something like that. Or if you had a non-programmer and they wanted to be able to parse or contribute to what you were doing, they would use something like Ansible. And Robot, I'll go into this a little bit later, it's a little more natural the way you write things. Below that, we have device abstraction. So think about how many network vendors you're dealing with at a given time. And I'm not just talking about routers, but I'm talking about like firewalls, load balancers. You're dealing with stuff that's virtualized, that's on a cloud network. You're dealing with stuff that's on-prem, that is manually configured. Everything's all different, and you can't necessarily go in and change what network vendor you use. You can't go and, well, not easily tell a network vendor what to do to get their API to change. And so this is where the abstraction layer comes in, and that's where Napalm comes in. And what we can do there is we can, on the back end, we can do something like talk to Arista's eAPI, or we can talk to Junos using netconf. But on the front side of things, where we present things to the user, we can be doing things like having get BGP neighbors can look exactly the same when you return things. And so this is important because by doing this, it's like an adapter layer. By doing this, you can expose things on other network devices that effectively look exactly the same as, like something you'd see on like a Cisco router for routing information. You can expose that on some other device that can run routing. You can add customizations or exceptions to these things, or extensions to these things, meaning that these Napalm specifically will allow you to, there's not much stopping you from going in and adding things to the network driver. And you can extend it to whatever you want to. So a good example would be like IPAM. You can connect into IPAM. So if you guys have some sort of an IPAM solution somewhere, you can do that to see what prefixes you have, what kind of addressing you're using, and you can make decisions based on that. You can also talk to things like netbox or netdot or rack tables, and those things will tell you things about your physical topology. And the problem with programming these things, the problem with coding is the assumptions you make about the physical world and the difference between what is and what ought to be. You don't want that to be very disparate. So to kind of have a lock on everything, you want to be able to hook into things like your physical space. You want that to be true. And below Napalm, Napalm specifically is tailored for routers and switches, but like I said, you can extend it. There's not a lot stopping me from going and editing so it can talk to like a big IP or something and use like F5's like SOAP interface or their REST interface. Okay, so the presentation layer, that top layer, that's designed for non-programmers. So the reason we have that is because let's say that maybe you don't even want to learn how to code and you just want to get in, you want to deploy change to a certain number of devices. You just want to get it done. You want it to be programmatic. Well, you can use the constructs of programming, like looping, like doing something with a timer, but you don't have to worry about that. You can do it in a markup language. YAML is a good example. I'm assuming that you guys have probably worked with YAML before. You'll see it everywhere. You'll see YAML and JSON and XML all over the place. So this is interesting because it can provide, it's the upper layer, it can provide reports and graphs and results and everything. So Ansible, Ansible is locked into using SSH for communication on devices. And so what we can do if we do select Ansible to use as like our top layer for things, you can present people, you can allow people to come with their own commands. So like on EOS, you can like pipe things out to JSON to get JSON output. And in this situation, in this specific example, you can use programming constructs like the construct of iterating, so you're iterating through commands. You can use a construct of looping, like in that wait for loop right there. It'll actually go, I think it's like a 1 second interval, it'll go 10 times to make sure that it can get connected on those interfaces. So this is like what I was saying earlier, you can give somebody programming without having them to understand a language. And Ansible is, bless their heart, they're trying hard to get into Python 3x, but 2 is very quickly dying. And they will eventually get into it, but it's like a 2.7 product right now. So Robot, I'm showing this as like an example of something that you can compare to Ansible. Robot just went out, this is open source by Nokia. They invented their own markup language. So it kind of reads like sentences. So when you look at the code, you can do imports above the settings. You can bring in these libraries. They have standard libraries that you can use, like telnet, opening connections, which opens like an SSH connection, just like Ansible does. These like list files, telnet, execute command, all those things are called keywords. And so what you can do in this, you can take like execute command down there, that ls, options path, that bottom line. That execute command is there's a class inside of their standard library in Python, and inside of that class, they have an execute command. It's execute underscore command is the function name. And this goes and it finds it, and it adds those arguments into it. So it's a lot like Ansible, because you can provide arguments, you can use code without having it look like code. The signature is the only thing you see. And this allows drivers to be written in Python or Java, so it gives you an option if you want to go, one way or the other. They're very different languages, but you can get the same result. So in your approaches to a solution, and especially in whatever you decide to do today, you need to be mindful of like your customer. So who's the next in line? Who's taking what you're doing and using it? Understand whether they're like a developer or not. Understand whether what their network experience is. One thing you want to like look at when you do decide to go and use one of these solutions out on the internet for all these problems, like these big abstraction layers, is how good is their documentation? Do you really want to be tech support for somebody? Like Ansible's got sweet documentation. Robot's documentation, it is tip top. These guys have had bug bashes just for their documentation. And it really shows. What you don't want to do is go and roll your own thing and have to support it and handhold people through it and everything. So, there's a trade-off here. So now, let's think about how we'll hide and abstract layers below. In this, the 80-20 rule actually kind of applies here because you'll never really find something that gets 100% of what you need. So, like I said, I like working in Python 3x, but if I'm going to use Ansible, that's kind of a pain. That's not going to work. If I can't use SSH, I have to use a bunch of different APIs, or I have to extend something. Maybe that won't work. Maybe Robot will be better. I'm not sure. You have to look into it and have reasonable expectations about what you need. So don't try to do too much with one solution. Be creative and try to extend something, but don't go too far. And don't get wedged looking for a perfect solution too. You might just need to move on. So keep paying attention to time with whatever you're working through. So there's certain things that you probably shouldn't reinvent. A good example would be like anything involving password hashing or salting or storing secrets. There's a lot of solutions out there that you can hook into from something like Napalm that store secrets in a more secure manner, like where you're pulling things out of a storage. It's using like a pretty strong hashing and salting algorithm, and you're pulling things out using public keys and private keys. So there's like authentication, and there's a paper trail. You don't want to redo that. SSH is pretty tried and true, so if you diverge from that, like if you're using bare sockets and you're you're passing things across the wire, essentially unencrypted. I don't know, maybe you should rethink your approach. And the other thing you probably shouldn't do is make your own markup language. YAML's pretty sweet. The reason I suggest kind of sticking to that is because usually you don't have enough time to do this kind of stuff. And the other thing you should always consider is that it's very likely, I mean, obviously you guys have probably been on Stack Overflow quite a bit. There's someone else on the internet that's probably been through this problem that you're thinking about. So it pays to know what to search for and the fact that someone else has probably gone through the same trouble as you. So the one thing that's cool about change control in development is that it's got kind of hard edges. It allows you to have control over what you're working on and copies of what you're working on and hand things around for review and look at diffs and everything without having to deal with like copying things around in files. This comes down to organization. So, and this is something you should probably think about today too. If you're copying around like Excel spreadsheets or you're like saving text files all over the place, that's when you can like step on your toes and things can get really awkward. Change control tools are pretty well understood and well documented, so things like Git can help you in a situation like this. And if you're ever dealing with someone that's used to development, this is already something they're used to. And you don't lose track, oh yeah, like I said, you don't lose track of multiple versions. So you can bring your own diffs. So when you're looking at configurations, and this goes with network configurations, this goes with your code. Some people like to use diff-y on the command line and look at stuff back like side to side. Some people like using the visual client. This is the visual client, the GitHub client. If you ever want to show something to somebody really quickly and show them what's changed, just like show them this. Get them the Git client, have them look at something and have them look at the delta. It pays to be organized, and sometimes people like to bring their own tools. This is just an example. And then this is the exact same thing, but on the command line. So this could easily be used. You can hand this patch around. You can use it for a review. You can use it to convey what you're going to do, and you can see changes pretty quickly. So this is a big one. The configuration deployments are really, it can get kind of crazy, especially when you have like semantic problems. So take, for example, there's two different kinds of errors generally, two classes that you can think of here. One of them is syntactic. And so a syntactic error is something that is going to absolutely just not work when you load it. Like the OS is going to just explode with some error where it can't parse something. So a good example would be like you tried to cat a file and you truncated it. You have garbage characters. Like, has anyone ever opened something like a Notepad on Windows or something and saved it and then seen the Windows like line endings? That stuff right there could just stop you dead in your tracks. That's like a syntax problem. And these network OSs all accept merge configs. So you can, well, they can accept multiple ways of putting a config onto a box. You can merge a config. You can stage an entire configuration to replace. So it's important to know the difference between syntax and semantic errors, because the semantic ones are a little more menacing, if you will. So like if I'm dealing with like v4 networking and I type in /33, that doesn't make a heck of a lot of sense. That's a semantic problem. So I like to call these like typos that somehow loaded. Or like another example would be like when you configure things that are just nonsensical with a protocol that allow things to flap between routers. That's an example of a semantic problem. So, like I said earlier, Napalm's got the network driver, and this is designed for routers. So they'll support Cisco and Cisco and Arista and Juniper, et cetera. They only have a handful of routers that they support, but that does cover quite a few products. It's a good reference implementation if you need to understand like the things you want to extend. The upper layer is Python, and the lower layer is the API and the back end of that selected network OS. Like I said, with Junos, it's going to use like netconf or SSH. With eAPI, it's going to connect to their HTTPS, or it can use SSH too. The network driver is pretty straightforward. They make it really easy to get into that. They're hiding. You can see where when you get the driver, you can specify what architecture you're dealing with. This is a lot like in Ansible when you are, what do they call it? They have a name for it. It escapes me. They do the same construct exists in Ansible because you need to be able to tell what API you're going to use, like am I using Arista or not. This can easily be put into a loop, and you can do things like discovering devices, listing information about them, and then each one of Napalm has a number of, if you look at that device right there, when you open that device and you run in Python, if you run vars on it or a directory on it, and you look at all the things it provides, getFacts is one of the things that it does. And getFacts is just a construct inside of Napalm. There's no like you don't type in getFacts on a router. getFacts is something that Napalm created that's like the version, it's getting chassis information, it's getting like uptime, and it has like its a little Python dictionary it hands back. So that's an example of like a thing that only exists in Napalm. But this is all at the this could be like, usually people do this drivers and everything at the first level of indentation in Python. So they provide a context manager. Do you guys, who in here doesn't know, who here knows how context managers work? Okay, so what these things can do is when you want to encapsulate teardown logic, for example, or you want to encapsulate some sort of error conditions that you know are going to occur, you want to hand that to somebody, you can use a context manager. And so what you do is in Napalm, this is the one that they had implemented. So you can go in, and this is just the connection to the device. So I'm using a really simple example because the underlying concept's kind of what I'm getting at here. In this situation, I'm just getting LLDP neighbors from a device, but when it falls off the end of that context, you'll notice that I do a device open down in the middle of that discover devices. What I'm not doing is a device.close. What it's doing, it's going to leave that connection open. So that's kind of lame. You should be tearing down the connections when you're done. That's kind of a bad programming technique. It's like when you're opening a file and you leave it open. That could get really confusing. This can get confusing as well because if you open a lot of connections to a network device, it might get angry. So this is how they solve that. They do a close when they come out of it. So what I did was I wanted to show the internals of a context manager. So in Python, this is like a copycat version of like that context manager. So this is a technique that you could use like in your development today. Like if you're using Python for what you're doing here, you can use this for something like rollback. Or you can use it to catch things like semantic errors. So think about the notion of like iterating through 1,000 routers or 1,000 devices, and you want to try and load configuration. You want to roll back if something goes wrong, or maybe you want to react to certain errors that come back. Like, you could react to an error like I loaded the configuration and then like a neighbor relationship, it didn't come up, like a BGP link didn't come up or something. You can handle that with something like a context manager. So in this situation, all I'm doing is I'm just making this new thing called Napalm session, and it initializes with the same things that the network driver would need, which is the username and the target. In this situation, I had the password. It has to use the password to connect to that device. That little get secret thing was something I made. So you can make a little function that goes and it grabs a secret for a specific device. And on this note, it's another thing to consider in network configuration. You'll notice that when you save like a router configuration, it's got like a hashed password. Sometimes people check, and I was mentioning using source control, never check in sensitive data to source control ever. You've got to do at least the first step to hiding stuff. So whether that's like, you could drop a file on your local file system and change mod it to only be owned by and readable by your user, and that is like a light year ahead of like writing passwords in source code. You should never do that. I just needed to mention that. So in this example, the enter is when you type with the context manager and you come back as a device. That device object right there is what comes out of that enter. So you're returning an instance of device, and this is just going to look like a napalm device. And then the exit, we're going to run a close. This is exactly what that previous context manager is doing. There's not a lot stopping you. That little star args right there is it's the exception hierarchy. So it's the tracebacks, the exceptions, and you can actually, in the exit function right there, you can do more fine-grained handling of things. You can say, like, if syntax error, do this. Log it, tell the user, send a guy an email. If BGP didn't come up, tell someone that routing loaded, but it wasn't correctly set up. So you can be really fine-grained about that. Context managers can get kind of like, there's shorthand for context managers, and that makes it so you can use them for kind of crazy things. Like, you could ignore everything with this if you wanted to. So this is a really funny pattern. Context lib is part of the standard library, and context manager is effectively the exact same code that you saw previously. It's just an enter and exit. All it has to do is yield, and that thing right there can be used as a context manager. So you can type, in this example, it's going to take any exceptions that you pass into that, and it's going to catch anything, and it's just going to pass. It's not going to do anything. It'll hide it, so you can swallow exceptions. That's a bad design pattern, hiding things and swallowing things, but if you just want to hit something with a huge hammer and move on, that's a good pattern. So like I said, imagine ripping through like 1,000 routers, putting configurations on every single router. The outer part, this is nested context management. So you've got, on the outer part, you've got the session where you're connecting to that target device. And then like right here, you're just trying to do a load replace with this bad configuration. Something goes wrong, you just move on. This is kind of a nonsensical example. It might or might not load, I don't know, but it was a typo in the configuration. And so what this will do is you can put this in a loop and you can iterate through all these thousands of devices. Maybe you want to go through on the next shot. So think about like how you would improve this. Like, let's not ignore everything. What would you do to it? You could, like I said earlier, you could be more smart about how you handle exceptions and how you handle weird situations. There are many different things that could happen. Just ignoring something is probably a bad example, but you could, the sky's the limit. Think about all the different things that have ever happened to you rolling out configurations to network devices, and you can kind of encapsulate that in a little context manager. You can hand that around. And so that logic doesn't get lost and it's repeatable. So one final thing I wanted to talk about was like extending automation. Another interesting benefit that you get from automating is that you can use things like heuristics. And in heuristics, it's really more like a guideline, not a rule. And it's more general. It's not so specific. So these are assertions maybe about large swaths of devices or large amounts of like data. You can go in and you can say, if this, then that. This isn't like hard requirements for something, but you can go out and scan across an entire network and you can ask questions like, how many routers are missing like enable passwords? Or is there some nonsensical BGP configuration that's been deployed that might have loaded, but it's causing links to flap? So these are the kinds of things that drive people absolutely insane because the approach that they take to these is really kind of inconsistent. Using something like napalm to go out and access all these devices, and this is just getting information, this isn't changing anything. It's really powerful because if you think in a larger scale, you can tackle a class of problems that take down huge networks all the time. And you can definitely find things too. When things are going wrong and you don't exactly know where things are and you need to bisect down and figure out where problems are in a network and what configuration was a problem, you can use something like a heuristic approach where you look at a large swath of devices and do like some basic checks across them. So when you're setting up your development environments, I don't know if you guys have used these tools before, but you probably used virtualenv to set up like a Python environment. There's two kind of major problems. One's your interpreter that you're using, the other one's all the packages and everything. What you want to be able to do is you want to be able to switch between interpreters, or you want to be able to switch between virtual environments. Don't get all crossed up. Definitely find a solution that works for you. My suggestion is PyEnv to install Python versions. So like I said earlier, Ansible is like a 2.7 framework. Hey, no problem. I can just pyenv install 2.7.13 and I'm done. Or you can install 3.6. It doesn't really matter. You can switch between them very quickly. PyEnv virtual env is a way to create virtual environments. It's just like virtual env. It's just an extension to PyEnv. And you can go to GitHub PyEnv, and that guy he's on top with documentation. So yeah, that's my suggestion for setting up your dev environment. So with that was just like a little teaser of what I had. That was just kind of getting you pointed in the right direction. Does anyone have any questions, answers about anything there? Oh, really?
Yeah, so I think at this point, officially supported is just, I haven't tested all the modules, but I use it exclusively in Python 3 and it's been pretty solid.
Yeah, because I tripped up on it, but I think I was using, the last time I used it, I admit I haven't used it recently. When I used it previously, it was when they were adopting 3x and not everything was working, and so I got kind of burned by it. And that's why I was actually using Robot. So they both have a lot of really like awesome features, and they have a lot of the same features too. 3x is sweet. You'll notice that I hid like an f string in one of those functions back there. Have you guys used f strings yet? Yeah, that's a good way of forcing, like underhanded evil way of forcing people to use 3x. Anyway. Anything else? So let's just say that, yeah, what it's going to do is, let's say that you're a programmer and you want to add, and you know a lot about Python, and you want to come in, you want to add like a completely new network OS. Ansible, it doesn't provide you the programming constructs necessarily. You have to create, Napalm is kind of like the lowest layer, really, that you could go between like a large set of devices. It allows you to kind of extend and use the same functions across a lot of different devices and have them present exactly the same. So it really comes down to, because in Ansible, you can do everything in Ansible if you wanted to. The problem is you're doing a lot of things in YAML that you could probably do like in a programmatic way in Python. You can encapsulate things and subclass things, and it's kind of easy to understand. And you're not dealing with the programming constructs that Ansible decided on when they decided how they were going to do looping or whatever. So, and the other thing is that they do a pretty good job of working with the different APIs and staying on top of the changes that these vendors are making to their APIs. Yeah, I think we're good. Is that it? Yeah, I think we're good.
Thanks, Bill. I'm going to switch back to my deck now.
Escape. Where do you want to go?
Just start with the next one.
Just go present. And we'll go full screen.
All right. So how many of you have come to a prior NANOG hackathon? I know, obviously I recognize a few faces. How many of you have been to any hackathon before? All right. How many first-timers? All right, decent amount. Awesome. So the way that we want to organize this is that we'll break into teams, and what I'm going to do is if you have an idea that you want to build a team around, I'm going to ask you to raise your hand. Any brave volunteers? Okay, 1, 2. It can be harebrained. 3. Any more hands? Okay. Yeah, we want to try to keep teams small. So if you have something an idea, or if you want to just get together with a group and hash out something, that's fine too. If you have an idea that you want to solicit people for, like I said, raise your hand and I'll pass the mic around. You can announce who you are and what your idea is and what you want to do. And once that's done, we'll get started. Before that, we have a Slack channel. Everybody should have had an invite to it. If you don't have access to the Slack channel, please let me know and we'll get you an invite. There is a idea pad that we've set up. Anybody can edit that. It's a Google Doc. And of course, we're all here. We can talk to each other. We have set up a number of virtual labs. I'll be passing on this information. We have this printed. You don't have to memorize all of this. We've got a few different lab topologies, and these are all virtualized labs that you can access, and we'll assign them out as needed. We have a Arista DC spine lab, 4 spines, 4 leaves, and hosts underneath. That is option number 1. Option number 2 is a WAN lab. These are Juniper VMX devices and a couple of test hosts. Everyone has a jump host, and the jump host is where you can log into and run your code, install code, and it should have all of the tools that we're talking about here already pre-installed, Ansible, Napalm, what have you. We have a few of the extra size labs, which is both the WAN and the data center. We've only got a couple of these, so if you think you're going to need to use a multi-vendor, let us know. We'll hand these out, first come, first serve. And we've got these all in sheets, so we'll hand you a topology diagram along with the access info. Just come to me and let me know what you want to do. Once we're done, 6 p.m., we're going to give each group a few minutes to present your work. Like I said, it can be rough. It can be a prototype. Don't get, obviously we want working code, but don't get too stressed out if you can't get everything working perfectly, or if you're using fake data. I've done that one myself too. Whatever you need to do to talk about what your idea is. Us, meaning the organizers, we'll pick a winner and a runner-up, and those ideas will then get a chance to present what they've done during the general session. We're going to have hundreds of people in there, no pressure, but you can show off what you've worked on, and everyone will see your work, and that'll be awesome. Is that the last hack? Is that the last slide? All right, I believe it is. All right, so like I said, if you have an idea, raise your hand and I will pass the mic around. All right, we'll start.
Hi, I'm Paul. I have a project that I was working on couple years back, and this project involves configuration management collection. And I never got, I got to the point where I did the Git checkouts and checking in, checking out, those kind of things, but I never got to a GUI, like a web front end to compare diffs, those kind of things. So if anyone wants to join me and work on GUI, you're welcome.
All right, next, anyone else? All right, join me first. You're closer.
Okay, my name is Flavio. Hi, guys. I put a bunch of stuff on the Google Docs, but I'm gonna suggest the one, at least somebody, the one that looks more feasible, which is canarying configuration changes. So we could, for example, use Ansible or Napalm and just do configuration changes one device at a time, and writing some verification, some sort of health check to check before proceeding to it, to all the devices. So that's just basically it.
Brandon Bennett with Facebook. So my idea will not win awards. We will not be at the top, but a while ago I wrote a netconf client for the Go programming language. It's the Juniper Go netconf. I wrote it when I first learned Go, and it is festered ever since. So I want to actually take the opportunity to go through all the issues, go through all the pull requests, and write unit tests, increase documentation, increase support, pretty much just make it a better package so that it's actually more usable, I guess. So if you're interested in Go or you know Go, you can come see me. If you don't know Go, I'll teach you. So it's easy.
And he can teach Go. I can attest to that. Anybody else? Anyone have an idea they want to put out there? We've got a type pad with a bunch of ideas. If you want to, if you have a group at your table, you want to talk about and grab one, that's fine too. All right, go ahead.
I'm not even convinced on this idea myself, but I'll throw it out there. And I also don't know if this tool exists, so I'm open to criticism about it. I've always wanted a tool to utilize SFlow better. You could fill in a particular flow that you're searching for, source and destination, and it would visualize the active path for a given flow compared to your physical environment. Just a thought.
All right, thank you. Anybody else? Going once, going twice? All right then, let's get started. Come up to, I've got the lab information here, so if you need access to a lab, come see me, and I will be handing these out. Let me get some background music started and let the hacking begin. Thank you. And time. And that's, and let me, oh, you turn it down? Awesome. Great. Okay, let me get our presentation set up here. I'm actually behind you guys at this point. Well, stop typing. That's a suggestion, not a rule. Don't do what I did at the first hackathon and run on stage while hitting right quit in a Vim window. Did I spell every team's name right? What was the right spelling? S. Okay, I saw a. Okay, we can fix that. It's all right. Give me a second. Yeah. Thank you all for sticking around. Hope you all learned a lot, and really looking to see what you have managed to prototype in this this long development cycle. So we wound up with 5 teams. Earlier, we went around the room and asked each team to nominate an MVP. And so here are your elections there. For Team Bump, we had Arohi. Stand up. All right. Thank you. For the Team The Canary, Flavio. Stand up, please. For the Chiefs, Paul. Net Makeovers, we have Kyle. Kyle, thank you. And Go Conf Yourself, Brandon. Should there have been a slash between the Go and Conf or not? All right, so what we're going to do here is we're going to give each team about a few minutes to plug in their laptops and show us what they've done. Afterwards, we will discuss amongst ourselves, and later this evening, you'll be hearing about our decisions on the winners of the hackathon. So let's go ahead in this order. Let me invite Team Buffs up to the stage right now. Wait a minute. I think you don't have an HDMI port. Good. Yeah, does anyone on your team have a laptop with an HDMI port? Oh, we have a mini display? Awesome. Okay. Technical difficulties, please stand by. Awesome, here we go.
Yeah, so hello everyone, a very good evening. We're Team Buffs from University of Colorado Boulder, Internet 2, and NetAlysys. We've come up with an APAM-based network management platform. Yep, so what's the hype about? It's a platform-independent software, I'll say, that we've created. It's a network management platform that works on Cisco iOS, Juniper JuneOS, Arista EOS, you name it, we got it. It's open source tool, NAPAM based. It's freely available. That's the awesome part about that. IPv4 and IPv6, there's no other IP coming in the near future, I guess. So it's all encompassable, all your worries solved. Observe, verify, change, and then party after that. So does this not make the network administrator's life easier? I'm sure it does. So why are we different? So we've come up with a network management platform. What it does is it makes data acquisition from your network a lot easier. There's BGP configuration details. We used the third topology that Oracle was talking about. We used that to show BGP configuration details in the leaf spine, as well as the WAN network of Junipers. Then there is interface level details that we get about MTU mismatch and all of those good stuff. Then there's device memory utilization indicator. If the device memory in your routers that exceeds a threshold, this network management platform would show you that. Some additional features that we thought we were going to include, but we could not include those today, was first was a cron job that continuously runs in the background, and that would this whole program would run in the background, and maybe whatever sensitivity you have in your network. According to that, it'll show you updates continuously from your network. And we have a script ready that sends mail notifications to the network administrator about any discrepancy that comes up in the network. We're going to show you a whole demo at the end of this, so if it's not making a lot of sense right now, just wait for the next 5 minutes, I'll say. Another thing that we have planned for the future is napalm logs. So napalm logs, what they do, they present you with a very simple and specific notifications. And our project here, that sends your telemetry state information. So both of these things combined give you a very robust network management platform. And what if the napalm connection fails? We'll say that additional napalm instances should be initiated and run from redundant systems and hosts as a means of, you can correlate feedback from those different instances, as well as this is a failover solution also that we've got here. So I'll hand over the mic to Arohi now. She'll start with the demo of how this whole system is working, and it'll start making more sense. So Arohi, you want to go ahead?
So this is just the code execution. And for each device, we have, can you zoom in? So we essentially had 8 Aristas, and we had 3 Junipers, which were the WAN. And for each and every device, what we thought is we focused on BGP, because since essentially it was a BGP architecture in whole, we are gathering the important parameters like timers, the configured hold time timers, the keep alive timers, what is the last event which you received for a prior BGP neighbor. We are calculating figuring out the local address, the AS numbers, if there is any discrepancy in entering the AS numbers, or in, let's say, 65,000 plus, a private AS number is advertised as a public AS. The router IDs and also the up connection, whether it is up or down. Any hold time essentially would be like the low negotiated hold timer would be taking place, but we still give you the data so that you can have a look. We also have a config test wherein we check if each device RAM is crossing a threshold of, let's say, 70%. All OK means it is, currently everything is fine with your device. A lot of parameters can be added over here. We just thought that device would be, since they are all running critical BGP updates, so it would be necessary. And overall, if you want to add.
Next, we focused on checking the MTUs for the links between routers. Over here, you can see the local MTU and as well as the neighbor's MTU. So with this information, you can easily find bad configurations in a network. Like if you have like 10,000 switches and 100,000 links, it is very difficult to go to every switch and check MTUs. This program could easily find this for you. Well, in BGP, it doesn't really matter, but if you're running IGP, then this is a critical problem. Your OSPF neighborship won't even form without these MTUs matching. We can also have run this script like a cron job, or after your automation script have run. So this could verify your automation scripts configurations on devices, and then can send you an email or whatever notification you choose to. This MTU can easily be extended to different parameters like subnet masks or duplicate IP addresses or MAC addresses on neighbors in between devices. So, but we just choose to have MTUs over here. Yeah. So this is our basically our hack. So this our hack helps you in debugging neighborship relationships. Probably like in the Facebooks and Google's data centers, you have a lot of devices, and debugging all of these neighborship is a critical task. It's a daunting task, so our tool gives you a helping hand in that. Also for newcomers who joining a team, it is very difficult for them to see what ASs are being used between devices and what neighbors are being formed. So this tool also gives you a brief overview of how how neighbors are formed and with whom. Again, it can be used for automating with a touch of verification. That being said, like you can verify what your automation scripts have done. Yeah, so this is what we did. Thank you.
Thank you. Impressive. All right, next team is the Canary. You can come up to the podium. You got HDMI? Yeah. Okay. Awesome. I think it's on the other side. There you go. Okay.
Yeah, I'll try. Okay, let's see what I can do. So I didn't do a nice presentation because I didn't have much time to do that. So just bear with me. I'm gonna talk a lot and try to explain what kind of what was the idea and what kind of we had help. Like we basically our team split up after lunch. So. But we still like discussed a lot, so I'm just going to talk about it. So the problem is that we all wish we had automation or software to deploy code or to deploy changes to our network, right? We wish we had a software that would just control everything, and you would change your software that would automatically go to your network. We know that still a lot of organizations are not even there. They don't even have the code. But even if you had, you would still have the problem that maybe now that you have the software, you're also vulnerable if you make a change that is actually adding a failure to your network or to your code. If that passed through your QA or your testing, then and you deployed that, if you deploy in your whole network, then maybe you just brought your whole network down. So everybody would wish that you would have a way to deploy that in segments, right? So the idea was to deploy changes incrementally. So you would configure one device at a time, then check the global state of the network. And if the global state is fine, proceed. That means everything's good. So until 2 p.m., so we spent most of the time kind of stuck. The idea, what I wanted to do was to leverage. I didn't want to be developing automation code, so I wanted to leverage code that's open source out there. So I tried to leverage some work by Cumulus. They have basically a way you can bring up a Vagrant environment that brings a leaf and spine architecture, a couple servers, and then you have the Ansible code that you can automate that. At first, we took a lot of time to download the VMs because the internet was pretty bad. So that has got us to about lunch. Then after lunch, at around 1 p.m., I realized they changed Quagga to this FRR thing, and basically nothing worked. And then I went there, replaced everything that said Quagga for Quagga to FRR, and then now the Ansible scripts worked, and that was great. So what that does is it brought up the Ansible thing. So now I needed to look at Ansible. What tools does Ansible give you to really do the testing, right? So the one thing that Ansible does give you is the ability to run to deploy the scripts, to run the scripts in sequence rather than parallelly. And you just have to set up. There's a parameter. There is serial. And once you set that to 1, that means that you run the scripts one node at a time. So that pretty much that pretty much delivers a lot of it. But now the problem was how do you check the state, right? So this was a BGP only leaf and spine fabric, and basically we're talking to some people and deciding what kind of metric could be used for that, right? So we talked maybe it could go into the hosts, and from the host you could ping everybody. We decided that would not be good enough because ping could still work, and maybe the network state could be damaged. So if you change, for example, one leaf, let me show a topology real quick. If you show, for example, one leaf, and just 1 second, guys. So for example, you could change leaf number 1 without breaking connectivity. You would still have ping connectivity. So we're like, okay, so that's not enough. We got to look at the state of the network. And what we kind of decided was to go with the number of neighbors, because that's kind of static. If the number of neighbors doesn't change, then everything's okay. At first, I wanted to avoid, because of Ansible constraints, because it gets kind of convoluted, because you have to go on each node, you make the change, then you gotta, it's still on that step of the script, you gotta check on each other node if the status is correct. And if you do that on Ansible, it doesn't make much sense, because, like I said, you're either doing one at a time or you're checking all the hosts. So that's pretty much the tricky part. And when we talked, we discussed, me and a couple folks, and basically we kind of have to take that piece out of Ansible, and that's where the hacking kind of began. So first, I tried to write a Ansible filter, which would parse the BGP summary output, and you would from that would parse the number of BGP neighbors that was there. So I did that, and after I did that, I realized that if I change a node in some way, so I could change one node and still get a output that looks kind of fine, but it doesn't really reflect the 100% accurately the state of the network. So I really got to go to the global state. So then I just kind of started really hacking, and what I did was I used the same code that I had to parse the script. I basically put it on each of the nodes, and in this way it's kind of running asynchronously, and each host kind of exposes that metric. So I just did a REST API, and the leaf then would call that REST API, and that is easy to do in Ansible. So, but that wasn't completed. So, but at the end of the day, the script, it runs and it deploys the changes. It also, if it fails, it will stop. I'm not gonna, I could try to restart something to induce a failure, but I'll just believe you guys are gonna believe me. But that's it, so that's it.
Thank you. Next up, we have the Chiefs. Could the Chiefs come up here? It's on the other side. Slideshow. There you go. There you go.
So, Chiefs present. Those are our GitHub handles. And what we're trying to do here is zero blow automation. So one thing you don't want to do is to blow up a network. So we decided that there are a lot of techniques that allow you to automate, to do the zero-touch provisioning. At the same time, there are not a lot of frameworks to do that. So there is POAP by Cisco, there is Arista, but at the end, you get two guys who would put that chassis into a cabinet, and they need to get that chassis started. So here is one of the ways to configure that chassis to accomplish the zero blow automation. So let's say that you have a device, R1, and that's the chassis that the two guys are pulling in. And the reason I'm not doing that is because I have a bad back, and I'm no longer able to carry the devices. Now what happens is, when you plug a device into a network and you plug a port into that device, by and large, you either have LLDP or CDP messages that will flow on the link. And when they do, you have a number of mechanisms to intercept those messages on the other side of the link. For example, router 2, which is your core network, your spine. So imagine that you have your spine and you provision every single port with an IP address. That would be point-to-point IP address. So by having the 10.10.10.1/30, and it's a point-to-point IP address, you by inference can figure out what the other end of that link should be in terms of IP addressing. So let's say R2 intercepted that event, and at that moment, R2 can update the network controller. It can be done via SNMP trap, it could be done by syslog and XMPP. Now, the network controller now can go to the terminal server, because usually when you pull the chassis in, you will run a console connection to a terminal server, and at that moment, you have devices visible to you through terminal server. Network controller will maintain a registry of all the devices that's connected to it, and one of the things that network controller has to figure out is the thing that makes a device unique. Usually it's a motherboard ID. With virtual devices, it's a little bit different. So imagine that so we run some Ansible plugin that allowed us to connect the inventory, the hardware details for a device that we found on the network, as well as the interface, show interface, which shows us the MAC address of device and maybe some IP configuration. All of that information would allow later on to provision the device. So let's say you didn't have an IP address, but the MAC address was the one that was seen within a CDP message, so you can act on it. So then what your network controller could do, it can go to the terminal server using napalm or any kind of other controller method and configure through the terminal server, not necessarily via SSH, it can configure that R1 that you just plugged into the network. It can set the IP address, because you already know what that second IP, or that's the other end of that pair should be. And you will check connectivity. Once again, you can do that via napalm or any kind of Ansible delivery. Maybe it's not even Ansible. Maybe it's a Tickle script. Whatever it might be. You configure loopback, and you IGP, and you're in the game. So then what you would be doing is you would be capturing, once again, some kind of a BGP summary command and understanding your peers along the routes. So in this case, VMX1 has 2 peers, 1 and 2, and there is probably, your network controller is smart to figure out that BGP is working. But that was outside of the scope of our POC. After you configure that through the terminal server route, now you can get creative with that. You can put XMPP bus, netconf, goconf, and REST API, and you can continue managing your devices and be creative with it. Thank you.
Thank you. And our next team, my screen locked. So next up, let's have the NetMikoers come up.
So we didn't actually make any slides, but we do have pretty little graphs. I'll get to exactly what they mean later. But what we were looking at was looking at improving the performance of NetMiko, which is a library used for connecting over SSH to many different device types. It's also what Napalm uses for a few devices. So essentially, inside of NetMiko, the current architecture is that it uses a while loop with an iteration count and a time to sleep in between each read of the socket. So if you get a large amount of data on the socket, it won't have subsequent reads very fast. It'll wait for that amount of time. And it'll also cause lots of context switches if you run many of these processes. So what we did is translated that to use select, which is a syscall which tells the kernel to wait on a file descriptor and wake the process up when it's ready. So after doing that, we see that a few different functions that we can do on, this is an EOS device. Connecting was about 2 times faster. Doing normal commands such as enable, show IP route were up to 20-ish times faster, and show run was, again, about 2 times faster. We also did this on Juniper. Connecting was about an order of magnitude faster, and generally at least 10 times faster for normal commands. Same thing for NXOS, 5 times faster for connecting, and 10 times faster for show IP route for 15. So essentially what this means is if you do use a large automation network like an Ansible or Salt with NetMiko or Napalm, this can greatly improve your overall performance when doing changes or monitoring. So that's what we got.
All right, thank you. And our last team is Go Comp Yourself. I think it was empty. I think we're good.
What's going on here? 1 second. Hello. We are team Go Comp Yourself. We took the Go netconf library. It was the tool that I used to learn Go 4 years ago. I wrote it, it festered, it stayed there. I was at Juniper, went to the official Juniper GitHub repository. And then the other day I found out I still have commit access to it. So we decided to make it better. What was the goal? Our goal was to make it better. Okay. I'm sorry. It's really boring, being that we just wrote a whole bunch of unit tests. We don't have fancy demos or anything, so I made up for it with PowerPoint skills. All right, here's the results. 7 issues that were closed. So we had like 19 issues when we started here. We closed, I guess we had, we're down to 9 issues right now. So we had 16 issues when we started. We closed 7 of them. It's pretty awesome. 19 diffs committed. So there were a number of diffs committed. A lot of them were unit tests. Some of them were actually fixing some of those issues. Some were just like renaming netconf to all uppercase. Very important diffs. Very important. All right, test coverage up 15%. So we started off with about 22% test coverage. We're up to about 37 now, but that's still pretty crappy. But at least we're trending in the right direction here. 2 new contributors. That was awesome. Animations, guys. I found this tab. I'll show you guys later. So 2 new contributors. So we got Jaden Wayne here. Wait. Okay. Wayne has never written Go before, so he was actually able to commit a couple of diffs, wrote some unit tests. Really great kind of learning and working with it, and we had fun. We had fun. That was another animation that was missed. Okay, thank you. And I got a demo. The test run. 2-feet.
Oh, yeah, I had a dash for you.
There's more than one test, so there's a whole bunch of tests, and they all pass. Thank you.
Thank you to all the team members. Give yourself an applause. Okay, let's get Matt with Oracle to handle the raffle for our lovely set of prizes we have here.
Thank you, Chris. So I'm Matt Reinzak with Oracle. First I want to thank all of you for coming out and participating. It's really our pleasure to be able to help, run this hackathon and work with all of you. This is new for Oracle and exciting for us. So again, thank all of you. Also, I'd like to thank Bill Booth for putting together the tutorial presentation and walking through that with everybody and supporting people throughout the day today. And now on to, I think, the important part, the raffle. So how do we want to do this? Just shake the list? Oh, cool. Do we have the list? So first, let's do the MVPs. I don't remember who they are because I've had like 3 hours of sleep, so I apologize. Come on up, folks. So what we have here are gift cards. We figured cash is king. You can take home a prize, but this fits in your pocket really easily, and you can get whatever you want. So please, each of you.
Thank you very much.
Oh, you're welcome. Here. We have an extra one. Okay.
All right.
Blind drawing.
One drawn. You must be present to win. So if nobody raises a hand, we'll pull another ticket.
Yep. Are we ready? 3, 2.
Where are we going to get up first?
Yeah, that's boring. Let's do an echo. What's the number? Let's see. Number is 013024. Anybody? No? 013024? No? Okay, let's try again. 025. Interesting. Not so random.
Randomize.
Our entropy is off, apparently. Let's see. 016. Surely this is a winner. No. Did we forget to give out tickets, maybe? What happened?
Get tickets.
Anybody? Bueller? Let's try again. 006. Oh, there we go. Excellent. You, sir, win one echo.
Thank you.
You're welcome. What's next? How about a Voyager weather radio? These are cool. 026. Yeah, we did 015. How did we have two? No, okay, no, they're just sequential. 007. The UC Boulder folks are cleaning up. Please, congratulations. Okay, I don't know what these are. Oh, Echo Dot, more echoes. Please. What do we have here? 020. There we go. Wow, these things really are small. I guess I didn't realize that. It may not be real. I'm not sure. It's too small. Okay, I don't know what this is. So, Bluetooth speaker, Bose SoundLink. Thank you, Chris. 021. Really? Oh, it's TJ?
Yeah.
Okay.
Got to be present to win.
Oh, you got to be present to win. We'll draw again. It was $1 million. Remember that. 013. There we go. We have a winner. Or maybe we don't.
Do we?
Well, interestingly enough, it's 013013. Does that help? Yeah. Yeah. Okay, next ticket. Oh, do we have it? Okay. There you go. I don't know what this is. Lucky balls. Oh, Bucky balls, cool. Aren't these illegal now?
They were.
Let's draw a ticket.
Okay.
015. There we go. Sir, be careful with us. Oh, mini espresso. Actually, this is kind of cool. We have here 022. There we go. Cool. There you are. Yep. And this is a prize. They didn't just come in these. Oh, it's a bag of holding. Very cool. 012. Ah, there we go. Here you go, Jeff. I'll take your ticket, sure. And one more Echo Dot. 027. Anybody? Well, more tickets. 023? Nope. 002. There we go. We can go this way too if you want. Sure. There you go. And we have one more gift card, so let's raffle this off too. 004. There we go. Perfect. There you go. Well, I'm glad that you got it here. Okay, so we are going to huddle and decide on the winner, probably over a little bit of alcohol, but that probably won't affect the judging too much. Also tomorrow we're going to present? Do you know about that yet? Okay, so we are also going to present to the NANOG conference tomorrow or Tuesday. We're working on the agenda for that, and we'll have details. As we announce the winners, we'll give you guys details about how that presentation is going to go and when it's going to be, as we figure it out. Thank you. Also, Chris, thank you. Thank you for all the help today, running all this. And I'll give this back to you. Yes.
And thank you all. And thank you to Oracle and everybody that came and did some pretty good hacks and had a lot of fun. I saw a lot of learning, which is probably the best part of getting it all together, is that everybody learns something and comes out of this with just one more skill, one more talent. You get to meet each other, talk, exchange war stories. I always love war stories. We have a social area over here, which is open bar and snacks as well for the next hour or so. Feel free to walk over here. And with that, I am turning this mic off. Thank you.